Okay, another topic in fluid mechanics, the principles of fluid statics. Let's consider this object having a cross-sectional area, let's call this A, and a length L. And these 2 points, point 1 and point 2, which lie in the ends of this object. So there is a difference in elevation, we call this h, and h is equal to L is the hypotenuse, h is the opposite side with theta here. So L is, or h is L sine theta. Okay. And this W here is the weight of the object. We can resolve this into components. Okay. So we call this W sine theta, and this one W cosine of theta. And since this body is at rest, we say that all the forces acting to it must be in equilibrium. So we apply summation of forces along x equals 0. So F2 minus F1 minus W sine theta is equal to 0. Yes. So F2 minus F1 is equal to W sine theta. Okay. And we know that pressure is equal to force over area, or force is equal to pressure times the area. Okay, another. Um, the unit weight, gamma, is equal to weight over volume, or weight is equal to gamma V, or the unit weight times the volume. And volume is equal to A times L. Okay. So from F2 minus F1 equals W sine theta. F2 is P2 times A. Okay. Minus P1 times A equal to W is gamma V. Gamma V. Okay. Sine theta. Okay. P2A minus P1A is equal to gamma. Volume is AL. Okay. AL sine theta. Oops. Cancel. Yes. So we have P2 minus P1 equals gamma L sine theta. But L sine theta is H. Okay. So, P2 minus P1 is equal to gamma times H. There. So, this means that the difference in pressure is equal to the gamma, or the unit weight, times the vertical distance between 2 points. So, ayun ibig sabihin nito, no? Or you can rewrite this as P2 equals P1 plus gamma H. Parehas lang din yan. Okay? So, another situation, what if uh, this point 1 is at dito sa may free liquid surface? So, what will be the equation? Okay? So, when point 1 is at this point, no, sa may liquid surface, the gauge pressure P1 will be 0. So, ang mangyayari dyan, that P is equal to gamma H na lang. Okay? So, ang ibig sabihin naman yan is that the pressure at any point, say H, no, below the free liquid surface is equal to the unit weight times the height, or H times H. Okay? Okay, another situation. What if point 2 and point 1 lie on the same elevation? Ibig sabihin, pantay sila. Ano magiging equation natin? So, H will be 0. Okay? So, if H is 0, P2 is equal to P1. Ayun, di ba? So, ayan ang mga dapat nating tandaan. Again, if point 1 is andito sa may liquid surface, so P1 will be 0. So, the equation is P equals gamma H. And when 2 points, they lie on the same elevation, so magsi-0 naman yung H. So, P2 equals P1. Okay? Yes. Consider this tank filled with 3 liquids, L1, L2, L3, and given the corresponding height, H1, H2, and H3. Plus, at the top, meron ditong air pressure. Now, to determine the pressure at the bottom, Summation of gamma H lang ito, no? Plus the air pressure. So we have, starting from here, we have PA plus the specific weight of the first times height 1 plus specific weight of 2, H2 plus specific weight of 3 times H3. So ganun lang, no? Summation of gamma H plus the air pressure. Okay, now the pressure head H is equal to the pressure over the specific weight. Now, this means that the height of the column of the liquid of unit weight that will produce an intensity of pressure. So, yan yung ibig sabihin ng pressure head. Okay? Now, to convert the pressure head of, let's say, liquid 1 to liquid 2. Okay. So, convert the pressure head of liquid 1 to liquid 2. Sulat natin. Convert the pressure head of liquid 1 to liquid 2. Okay? That is H2 equals H1 times the specific gravity of the first over the specific gravity of the second liquid. Or, pwede rin to as in terms of density. We have H1 times rho 1 over rho 2 or density 1 over density 2. Or in terms of unit weight, pwede rin siya as H2 equals H1 times the specific weight of the first over the specific weight of the second. Okay? So, madali lang. Now, to convert any liquid, no, or pressure head of any liquid to water, just simply multiply the height of that liquid times its specific gravity. Okay? So, convert the pressure head of any liquid. Sulat natin, no? Any liquid to water. Okay? So, that is height of water, okay, equal to the height of the liquid times its specific gravity. Ganun lang, no? So, ayan, mga kailangan natin itong mga formula. Okay, so let's have some examples. Okay. Problem 1, if the pressure 25 meter below a liquid is 400 kilopascal, determine its unit weight, mass density, and specific gravity. Okay, solution. To determine the unit weight, so we have pressure equals gamma H. Gamma is equal to pressure over H. Pressure is given 400 kilopascal over height, H, 25 meter. So let's compute. So we have 400 divided by 25 equals 16. So 16,000 or 16 kilonewton per meter cube. Okay. Now, to determine the mass density, we know that the specific weight is equal to mass density times the acceleration due to gravity, or rho is equal to the unit weight over g. Okay? So, we have rho equals 16 times 10 raised to 3 over 9.81 meter per second square. Okay? So, ganun lang. So, this is equal to, so let's divide this by 9.81. Yes. So, 1,631. Round up na natin, no? 1,631 kilogram per meter cube. Okay? Yes. How about the specific gravity? Okay, the specific gravity of the liquid is equal to the unit weight of the liquid, ito yon, no? Over the unit weight of H2O. There. So, specific gravity of the liquid is equal to 16,000 over 9,810, okay, or 9.81 kilonewton per meter cube. This is the specific weight of H2O. So, the specific gravity of the liquid is equal to So we have, divide this, 16 divided by 9.81. And we have 1.63. Okay? So, ganun lang siya i-solve. Okay? Problem 2, a barometer reads 755 millimeter of mercury and a pressure gauge reads 400 millimeter of mercury. What is the absolute pressure in the tank where the gauge is connected? Okay? Solution, to solve for the absolute pressure, P absolute, so we have this formula, ATM plus the gauge. Okay, there. So atmospheric pressure plus the gauge pressure is the absolute pressure. Okay, this problem, ang sabi rito is mercury. Okay, if mercury, the specific gravity of mercury is 13.6. Sa mga exam, sa board exam, hindi na binibigay ang specific gravity of mercury. Dapat yan ay alam na natin, no? That specific gravity of mercury is 13.6. Okay? So, let's solve the P absolute. So, atmospheric pressure or PATM is equal to, this is gamma H lang din naman ito, no? So, 9.81, okay, this is the unit weight of water, multiply by the specific gravity of mercury, 13.6, times height. Ano ba yung height dito sa barometric natin? Barometric reading is 755 millimeter or this is 0.755. Okay? Then you add the gauge. Ano naman to? This is the specific weight of water, 9.81, times 13.6 times the height, gauge reading, which is 0.4. Okay? So, nakakilo tayo dito since this is the unit weight of water, 9.81 kilonewton per cubic meter. Okay? So, we have P absolute equals, let's use our calculator. And this is what? 9.81. Ikaw ng parenthesis, no? Pwede rin namang wala. Sige na nga, wala. 9.81 times 13.6. Okay. There. 13.6, no? So, i-add ko na lang yung dalawa. Parehas lang din naman. So, 0.755 plus 0.4. Same lang yan, no? Pinactor out ko lang yung 9.81 by 13.6. So, the answer is 154.09 unit kilopascal. There. So, this is the answer. Problem 3, if the pressure at the point in the ocean is 80 kPa, what is the pressure 25 meter below this point given S equals 1.03? Okay, solution. So, the difference in pressure between 2 points, P2 minus P1 equals gamma H. Okay, so P2 is equal to P1 plus gamma H. So, P2 is equal to 80 plus the unit weight, which is 9.81, times the specific gravity, 1.03, times the height of 25. So, this is P2. Okay, so P2 is 80 plus 9.81 times 1.03 times 25 equals 332.61. Okay, kPa. There. Problem 4, a water barometer reads 10 meters. What will be the corresponding reading in an alcohol barometer given S equals 0.84, neglecting vapor pressure? Okay, solution. So first, convert the water barometric reading to kPa. So we have PATM is equal to gamma H, no? Gamma is 9.81 times 10. Yeah. So we have Ilan yan? 98.1. 98.1 kPa. There. Then, the next step is yung alcohol barometer naman natin. Ano? So, we have ATM, which is equal to 98.1 equal to the alcohol barometer naman. No? So, 9.81 times the specific weight, which is 0.84, multiplied by the height, which is, yun ang hinahanap natin. No? The corresponding reading in an alcohol barometer. There. So, H, therefore, is equal to, so we have 98.1 over 9.81 times 0.84. Okay, equals there 11.90 90 meters. Problem 5, if the pressure in the airspace above an oil S equals 0.8, surface in a closed tank is 120 kPa absolute. Okay, what is the gauge pressure 2 meter below the surface? Okay, so we have, say, P equals PS, surface, no? Plus gamma H. But the pressure, ito, is given in absolute. So, kailangan natin i-convert ito in gauge. So, PS is equal to absolute, no? So, 120 minus the atmospheric to 101.325. Ayan. Ito yung atmospheric pressure natin. Hindi yan given, pero dapat yan ay alam na rin natin, no? But PATM is 101.325. Okay, so PS equals, we have 120 minus 101.325. So we have 18.675. There, kPa. Then, you're ready to solve the gauge pressure 2 meter below the surface. So we have 18.675 plus gamma H. Yan. So 9.81 times oil, no, 0.8 times the height of 2. There. So P equals, so add 9.81 times 0.8 by 2 equals 34.37 kPa. So this is the gauge pressure 2 meter below the surface. Problem 6, a tube 5 meter long is inclined at an angle of 75 degree with the horizontal ends filled with water. What is the pressure at its bottom? Okay, so solution. Okay, H is equal to L sine theta. Okay, H is equal to L is 5, then sine theta is 75 degrees. Okay, so H is equal to so 5 sine of 75, we have 4.83 meters. There. Then, we can now solve for the pressure at its bottom. Water naman ito, ano? So, we have P is equal to gamma H. So, we have 9.81 by 4.83. So, P is equal to, let's multiply this by 9.81. We have 47.38 kilopascal. There. Problem 7, a pressure gauge 6 meter above the bottom of the tank containing a liquid reads 90 kPa. Another gauge for meter reads 100 kPa. What is the unit weight of the liquid? Okay, so we have solution P2, Diba? Equals P1 plus gamma H. There. Okay? So, to determine the unit weight, so we have P2 minus P1 over H. But H is the difference in elevation between uh, the two gauges, no? So, we have P2 minus P1 over H. So, this is the gamma. Okay, this is the unit weight. So, we have P2 is given 100. Okay. Then, P1 is 90 over, anong gagamitin natin? Difference lang, no? So, 2. 2. Yan. Then, gamma is equal to 10 over 2 is 5. So, 5 kilonewton per meter cube. This is the answer. Problem 8, a pressure gauge elevation 8 meter on the side of the tank containing a certain liquid reads 57.4 kPa while a second gauge at elevation 5 meter reads 80 kPa. Compute the specific weight of the liquid. Okay, solution. So we have difference in pressure, P2 minus P1 equal to gamma H. Okay, P2 is 80. P1 is 57.4 equal to gamma, and the difference in elevation, we have 8 minus 5. So gamma is equal to, okay, so we have 80 minus 57.4 divided by 3. There. So we have 7.53 kilonewton per meter cube. There. Problem 9, assuming specific weight of air to be constant at 12 Newton per cubic meter, what is the approximate height of Mount Banahaw if a mercury barometer at its base reads 654 mm and at the same time another mercury barometer at the top reads 480 millimeter? Okay, solution. So we have P2 equals P1 plus gamma H. P2 is, ito yung reading sa base. So we have 9.81 times the specific gravity of Mercury multiplied by the reading, which is 0.654. Yes, equal to. And P1 is 9.81 by 13.6 multiplied by 0.48 plus gamma of air. Lahat ito nakakilo. So, 12. So, gawin natin itong kilo din. 0.012 times height of Mount Banahaw. So, height is equal to, okay, calculate. So, we have 9.81 there times 13.6. Okay, so multiplied by ililipat natin ito sa kabila, no? Okay, minus na lang natin. So, 0.654 minus 0.48. Okay, equals divided by 0.012. There. So, the height of Mount Banahaw is 1,934. 1,934.53. 2. Okay, meters. So, ayan, ganyan pala kataas yan. Okay? Yes. Last number, problem 10. Closed tank contains 3 fluids. Fluid 1 is water, S equals 1, and depth is 2 meters. Fluid 2 is oil, S equals 0.8, and depth is 3 meters. Fluid 3 is air having a pressure of 25 kPa. An open manometer with mercury as its base fluid is connected to the side of the tank at the lower portion where water is located. The deflection of mercury is toward the open end of the manometer, where the level of contact with the water is 0.5 meter below the bottom of the tank. Okay? Then find the deflection of the mercury. Okay? So here, so So, meron tayo dito, ano, air pressure at the top, then oil, then water, given the corresponding height, plus may 0.5 pa sa baba. Mercury daw yung base fluid. What is the deflection of the mercury? Okay, so diretso na natin. So, solution, from here, we have 25 kPa. Then, we add, okay, 9.81 by 0.8. Ito na sa oil, no? Times the height, which is 3. Okay. Then you add water. So we have 9.81 times 1 times, ano yung height? 2 or 2.5? 2.5. Yes. 2.5. Then minus, dito kasi, yan, akit na tayo, no? So minus 9.81 times the mercury, specific gravity, no? Multiplied by the height equals 0. Yes. So, meron na tayong isang unknown. So, masasolve na natin siya using Casio. Yes. There. So, we have, so 25 plus, sige, 9.81 times 0.8 by 3. Okay. Then, plus 9.81 times 2.5. Okay. Then minus 9.81 times 13.6. Okay. Lagyan na natin ng unknown x. There. Equate to 0. There. Shift solved. The answer is 0.54708. Okay. There. So this is the answer. Okay? Yes, very easy.